Hi, welcome to Igcse and A-level chemistry classes. In this video, we are going to discuss about metals. Metals. In periodic table, most of the elements are metals. Example for metals: silver, gold, platinum, sodium, potassium, calcium, magnesium. These are example for metals. Properties of metals. First one, physical properties of metals. Metals have high melting and boiling point. Metals are malleable and ductile. Metals are malleable mean metals can change to thin sheet. By applying high force, we can change metals to thin sheet. That is, metals are malleable. Metals can convert into thin wire, electric wire. That is, metals are ductile. Metals are malleable and ductile. Metals are sonorous. Metals are sonorous mean metals produce sound. Metals are good conductor of heat and electricity. Metals are good conductor of heat and electricity. Okay, these are the physical properties of metals. Metals have high melting and boiling point. Next one, we have to discuss here alloys. Alloys mean mixture of molten metals. Mixture of molten metal. Here pure metals convert into alloy because alloys showing better qualities compared to pure metals. Alloys resist corrosion. Alloys are harder than pure metals. That's why pure metals change to alloys. Alloys mean mixture of molten metal. Alloys are mixture. So alloys which consist of different type of particles. Alloys consist of particles with a different size. Okay, so particles cannot slide each other. Particles cannot move each other. That's why alloys are much harder and stronger compared to pure metals. See this diagram, pure metal and alloy. Pure metals mean it consists of only similar particles. Alloys which consist of different type of particles or particles with a different size. Okay, so particles cannot move each other and they are much stronger and harder. And also alloys resist corrosion. Example for alloys: brass, bronze, stainless steel. These are example for alloys. Brass which consists of copper and zinc, and brass is much stronger and resist corrosion. That's why brass it used for electrical fittings and car radiator. Bronze which contain copper and tin, and it is harder and stronger. That's why bronze used to make statue, springs, coin, etc. Third one, stainless steel. Stainless steel which contain iron, chromium and nickel. Iron, chromium and nickel. Stainless steel do not rust. Okay, that's why it used to make kitchen sink, chemical plant, cutlery, etc. Okay, next one we have to discuss here, reactivity series. Reactivity series mean arrangement of metals according to their reactivity. Arrangement of metals according to their decreasing order of reactivity. See here, potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, lead, hydrogen, copper, silver, gold. This is reactivity series. On moving from top to down, reactivity decreases. Sodium, potassium, sodium, calcium. These are the metals on the top. Metals on the top highly reactive, even it react with cold water. Okay, and metals such as zinc, iron, lead, zinc, iron, lead. These are moderately reactive metal. Moderately reactive metal. Metals on the bottom, copper, silver, gold. These are on the bottom part. These metals are highly inactive. These metals are unreactive, do not react, do not involve any type of chemical reaction. These metals are unreactive metal. Silver, gold, platinum. These metals obtain in the pure form in the nature. Silver, gold, platinum. These metals obtain in the form of pure nature. It obtained in the nature in the pure form. That's why these metals are called native elements. Native metals or native elements. Look here this is the arrangement of metals according to their reactivity. Here I included, here you can see carbon and hydrogen. Carbon and hydrogen, these are not metal, but we include here carbon and hydrogen to compare their reactivity. All metals above hydrogen, look here, lead, iron, zinc, carbon, aluminium, magnesium, calcium, sodium, potassium, these are the metals above hydrogen in reactivity series. Metals above hydrogen in reactivity series, these metals can displace hydrogen gas from its acid. Example, hydrochloric acid, nitric acid, sulfuric acid. Okay, these are example for acid. Okay, metals above hydrogen, for example zinc, it can react dilute acid and form hydrogen gas. Zinc reacted with a dilute HCl, it form hydrogen gas. Calcium can react with sulfuric acid and it form hydrogen gas. It's mean metals above hydrogen react with a dilute acid and form hydrogen gas. Okay. Next one, look here, metals above carbon, for example aluminium, magnesium, calcium, sodium, potassium, these are highly reactive metal. Okay, metals above carbon, its metal oxide cannot reduce by carbon. Means sodium oxide cannot reduce, cannot remove oxygen by carbon. Sodium oxide reacted with carbon, sodium and carbon monoxide do not formed because it's metal oxide above carbon. For example, aluminum oxide, magnesium oxide, calcium oxide, this metal oxide cannot reduce, cannot react with carbon and not forming any type of product. But metals below carbon, for example, zinc, iron, lead, this metal oxide can be reduced to metal by carbon. Zinc oxide reacted with carbon form zinc and carbon monoxide. Fe2O3 can react with carbon and form Fe and carbon monoxide. So here metals above carbon, their oxide cannot be reduced by carbon. Example, sodium oxide, potassium oxide, aluminum oxide cannot reduce by carbon. But metal oxide below carbon, for example zinc oxide, iron oxide, lead oxide can be reduced with carbon. Zinc oxide reacted with zinc oxide plus carbon form zinc plus carbon monoxide. Fe2O3 plus carbon form Fe plus carbon monoxide. Okay. Look here aluminium, it is above carbon, it is highly reactive metal according to reactivity series, but usually aluminium it is highly unreactive because on the surface of aluminium there is a layer of aluminium oxide. Pure aluminium it is highly reactive, but on the surface of aluminium there is a oxide layer, aluminium oxide. Okay, this oxide layer it is it is strong and harder, and this aluminum oxide layer, it protects aluminum from further chemical reaction. That's why aluminum on the top of reactivity series, but usually it is highly inactive. Okay, next one, displacement reaction. Next one we have to discuss here, displacement reaction. Displacement reaction means a more reactive metal can displace a less reactive metal from its compound. This is called displacement reaction. In reactivity series, we know in reactivity series metals are arranged according to their reactivity. Okay, for example, zinc and iron. Zinc is more reactive than iron. Okay, so a more reactive metal can displace a less reactive metal from its compound. Zinc is more reactive, it will displace copper from copper sulfate. Zinc plus copper sulfate form zinc sulfate plus copper. More reactive metal displace a less reactive metal from its compound. Copper sulfate, it is compound. Okay, so zinc reacted with copper sulfate, copper replaced with zinc. Product is zinc sulfate plus copper. Such type of chemical reactions are called displacement reaction. The bigger difference in reactivity series between two metals, the faster the reaction. For example, in reactivity series, I discussed before reactivity series, you can check reactivity series. Okay, sodium and copper. There is big difference in sodium and copper. So sodium reacted with copper sulfate forms sodium sulfate and copper. This chemical reaction will be much faster than zinc plus copper sulfate. Zinc and copper, here zinc is more reactive than copper, but zinc and copper, these two metals are close in reactivity series. So this chemical reaction will be slow compared to sodium plus copper sulfate form sodium sulfate and copper. Why? Because sodium and copper, there is big difference in reactivity series between sodium and copper. So see here some example for displacement reaction. Zinc plus copper sulfate form zinc sulfate plus copper. Okay, we can write its ionic equation. Zinc plus, in copper sulfate, Cu2 plus and SO4 2 minus. Zinc plus Cu2 plus giving, in zinc sulfate Zn2 plus and SO4 2 minus. So Zn2 plus Cu. So ionic equation for zinc plus copper sulfate giving zinc sulfate and copper. Zn plus Cu2 plus gives Zn2 plus Cu. Look here, another chemical reaction. Sodium 3Na. Look here, the question coming here, Na plus Al3 plus gives dash. Na plus Al. We know sodium, it is group 1, Na plus Al. Also we have to balance this. We have to balance this equation. Al3 plus Na plus. So to make it balance, Al3 plus mean it need 3 sodium. Al3 plus means aluminum with 3 positive charge. It receive 3 electron. Sodium its valency 1. Sodium lose 1 electron. But aluminum need 3 electron. So we have to balance 3 sodium plus 3 Na plus Al3 plus gives 3 Na plus Al. To make it balance, it is very easy. Al3 plus. So what is the charge of aluminum? 3 plus 3. So we have to multiply sodium with 3. So 3Na 3Na plus. And the next one here, sodium. What is the charge of sodium? Charge of sodium 1, Na plus. So we have to multiply Al3 plus with 1. Okay, so just multiply sodium with charge of aluminium. Also multiply Al, multiply aluminium with charge of sodium. Okay.